Welcome to DevTotal. In this video, I'm going to teach you how to code like a pro using Rojo and Visual Studio Code, just like other developers have done who created super successful games like Adopt Me, Jailbreak, and Tower Defense Simulator. Roblox Studio is awesome on many levels, but it lacks a world-class code editor and version control integration. As your games and underlying code become more complex, better code management is needed to keep track of all your changes and cut down on development time. As your game grows, you might be adding new members to your team and will need an easier way to work together. Visual Studio Code is a very popular free IDE in the development community for full stack development for both front-end like CSS and JavaScript, but also server-side coding using Python, C#, Java, and PHP to name a few. We'll be using it for Lua development, relying on the very cool Rojo VS Code extension. Okay, so let's figure out how to install all the software. To do that, go to rojo.space, click on Get Started, and then we're just going to go to Installation, and let's see what they say. If you use Visual Studio Code, you can install the Rojo VS Code extension. This is actually the path I recommend. To download Visual Studio Code, go to code.visualstudio.com/download and just download for Windows or for Mac. I got a Windows machine, so that's what I downloaded. After you've downloaded Visual Studio Code, go ahead and open it. And then you want to go and click on the extensions button here on the left hand side of the menu. And then we're going to search for the Rojo plugin. And the one you want is created by Avera. So I'm going to click on Install. Now go create an empty folder somewhere on your hard drive. I like to stay organized, so I have a dev folder, and underneath there I have different folders for different technologies. In this case, I'm coding in Roblox. So let's create a new folder. What do we want to call this? Let's see, Roblox underscore, I'm just going to Rojo test. Okay, and let's go open up Visual Studio Code and click on File, Open Folder, and then we're gonna go ahead and open that folder. Where is that? Oh my god, I work on so many different projects. There it is, Roblox Rojo test, select folder. Okay, so you should now have your empty folder opened in VS Code. So it's essentially now an empty project. Rojo does not exist in there. No artifacts have been created. We want to go ahead and use the VS Code command palette to create those artifacts. To do that, press Ctrl, Shift, and P together. If you're on a Windows machine, if you're on Mac, it's Command, Shift, and P. So then you want to type Rojo, open menu. For me, it's just popping up right now, so I click that. What are our options here? So it says Rojo is not installed, so that's pretty cool. It knows in this empty folder Rojo has not been installed. So what do we want to do? We want to install Rojo now. So let's go ahead and click that. So it set up this little file called admin.toml. Press Ctrl, Shift, and P again to get to the VS Code command palette, and let's type Rojo and click on Open Menu. And now we see different options available. We can now create a workspace folder. So basically, there's no Rojo project files yet, and we're going to run Rojo init, the Rojo init command that's based on that Rojo plugin that we installed earlier. So we click that. Cool, and look at all these artifacts that have been created. So we have a source folder. It actually also did a git command, so it initialized the local Git repo. and it added some get ignore files in there. We'll go over that a little bit later. And there's a JSON project file. We've now got our basic Rojo project files set up. Now it's time to create our place file. To do that, press Ctrl+Shift+P, type in Rojo, click Open Menu, and then if you hover over your project here, the default project.json entry, and you go all the way to the right, there is an entry to build the project. Click that first. And you'll see here on the left, or in the project hierarchy, you see the Roblox Rojo test.rbxl file has been created. Let's go open that rbxl or place file. To do that, go into Roblox Studio, click on File, open from File, browse to the project directory. In this case, it's Roblox Rojo test, and then double click your project file. I now want to go over what I feel is a very important part of this whole setup, which is the mapping from VS Code, the script mapping, to Roblox Studio, how it's viewed in the workspace hierarchy. So if you open the source folder in VS Code and then the client folder, you'll see a file called init.client.lua. And in there, there's code that prints out hello world from client. This is boilerplate Lua code that's been added in different areas to kind of get you started. So that client code maps to, if you go to in Roblox Studio to starter player scripts, and you double click on client, and then you'll see that code there. It's basically that same file that's being opened right now in Roblox Studio, okay? And that will run the client script. Now if we go to the server folder back in VS Code and you click on init.server.lua, you'll see code that prints out hello world from server. To find that in Roblox Studio, you will go to the server script service and click on server, and there's the code, okay? Then if you go to expand the shared folder in VS Code and click on hello.lua, you see there's a function that's being returned that just says hello world. To find that in Roblox Studio, you will go to replicated storage common hello. Double click on that file and you'll see that same code in there. Now we want to work on getting this syncing to be automatic between VS Code and Roblox Studio. To do that, you got to make sure you have your Rojo 7 plugin installed. If you don't, go to the plugin menu, click on Manage Plugins, click on the plus button, and then in the search type Rojo, and then click on the version you need to install. In this case it's number 7, and install it. You should now have a Rojo entry in the plugins tab in Roblox Studio. If you click on it, you'll probably get this message: couldn't connect to the Rojo server. Make sure the server is running. Use Rojo serve to run it. So the way the connection works between VS Code and Roblox is that VS Code, the Rojo plugin in there, will actually serve the files, manage the syncing via a locally hosted server. So to do that, let's jump back to VS Code, and then here at the bottom on the blue ribbon, you'll see Rojo. Just click on it, and then just click on the play button to the left of the default project.json entry. Okay, and then if we click if we expand that message that popped up in the bottom right, it will say that Rojo server is listening at the following location. And if you go ahead and open up that location, that URL, you'll see the actual server being hosted on that port, the Rojo server, and then you can look at the instance tree. But essentially, if you refresh this and you see the Rojo if you see the Rojo logo, you know the server is being hosted and everything's working just fine. Now let's go back to Roblox Studio, and now we just clicked on OK and it disappeared, that little error message. Click on connect and boom, it's actually, the connection has been made. Now let's see if we can change a file in VS Code and see if it's going to be updated here in Roblox Studio. Because the way you're going to be coding is, you're not going to be coding in Roblox Studio, you're going to be coding in VS Code, and it will update Roblox Studio. So let's go back to VS Code. Let's go to a client file. Hello world from client. Sync is working. Let's actually hope this is going to work. Then you save it. Go back to Roblox Studio. Let's click on the client file. Oh, there it is. And I wonder if it's going to be updating as I'm saving. So let's put this side by side. And hello world. Let's put 3 exclamations and we save it. And you see it was immediate. It changed here immediately on the left hand side. So it's pretty neat. Always remember to work when you're coding. If you're using this plugin, you work in VS Code when you're scripting. Okay, that's where you will do all your major development. Let's go ahead and click play and see what output we get. Okay, so we get first the hello world from server and then hello world from client. So that's kind of the order in which those are being run. Now you would see the shared hello.lua file, which just prints out hello world, is not being printed out. It's just because we're not calling that service or function yet. Let's talk a little bit about version control and specifically Git. Git is the most popular version control software available, with GitHub being the best or most popular platform to share your work with other team members or the world with. The way it works is when you run a git init command, which was done with you when we set up this boilerplate Rojo code, you have a local Git repo that was initialized. And to get to that local repo, you can go into your Roblox project folder and you'll see a .git folder. Okay, if you don't see that, you just have to go into your file properties and make sure you can view hidden items. If you unclick it, you'll see it's gone. If you click it, now you're seeing it again. Okay, if you double click on that, you'll see the configuration for Git. In this case, we can click on the config file. And let's open it just in Notepad. And there's just some basic information about that local Git repo. Basically, it's just using a file system to keep track of your files. So any kind of change that you make, it's going to be keeping track of it. It's additive. It won't ever destroy. It's just always adding information, so you can never really lose information as you're checking in or committing your file changes. So we have not made our initial commit yet with all these changes that we've had in this project. So if you go in VS Code and you click on the source control entry here on the left, the menu item, we'll see all these changes over here that have been made. So first, there's a git ignore file that was added. Now this git ignore file is basically saying when we're performing commits, when we're checking in, ignore these guys. So we don't want to check in any of the log files, and you can add other files in here. For instance, let's say you had images that you didn't want to check in. You can say maybe ignore star.ping files or star.txt files. For now, don't change anything. Just use what's given to you out of the box. But basically, this code will not be tracked. So it's usually related to metadata, project metadata. That's not really, code based, and you don't need this to reinstantiate this project. If someone else were to get your access to your repo, they can basically reproduce it without needing these files. And then we'll see these Lua files that were also added. So what we can do right now is we always have to add a commit message. So I'm just gonna say initial commit, and then I commit it, okay? There are no stage changes to commit. So yeah, actually I had to, let me go back first. If we hover here over changes, we can stage it. So what happens is first the changes are made, and you'll be able to see that here in this window, and then you have to stage it by clicking plus on all of them or on the individual ones. And now these are the stage changes. They've actually moved from changes to stage changes, and you can remove them if you made a mistake, or you can just type your command and you can say commit. Okay, so now it's been commit to a specific branch. You can create multiple different branches. We just have I'm just using the main one now, which is called the master branch. But you can create like a dev branch or multiple different branches, feature branches, hotfix branches. I'm not going to get into that now. And then you can also publish the branch if you wanted to, and that usually will publish it to GitHub. I'm not going to get into that, but that's if you want to push your changes from your local repo up to the cloud to share with other folks. That can be done through GitHub. Okay, but just know that for speed, you are always working on your local Git. That's how it was created, your local Git repo, and then you can share it by pushing it to an upstream branch. That's usually called like the origin branch, and you can also pull from it, and that way you can kind of share your files or your work with other team members, okay? Or it's also a way to kind of back it up in the cloud. So let's go ahead and let's make a change to this hello.lua file, and we can see the change in there. So hello world, this is a change. Okay, we save it, and once you save it, here on the left hand side, if you go to the source control menu item and you click now on that file, you'll see a nice little comparison. It will show you on the left what it used to be. Okay, it's kind of saying, hey, this line changed to this guy over here, and this is the change. And now again, we can just click plus to stage that and enter a comment, altered current statement. You try to make this descriptive so that 6 months or a year from now, if you come back or other people have to work on it, or you have to debug something, you kind of figure out what happened. It's a really good way to track all your work and build quality software. Another cool feature of this setup is that you be tracking changes to your place file or RBXL file. So if I go ahead and add a part in here and then I save it. So I save it to file, and I go back into my VS Code and I click on the changes. We'll see there's this RBXL file has been changed, and now we can go ahead and commit that change. Added a part. Let's stage it first and we commit it. And now if we, let's say, made a mistake and we want to erase all those changes, we can actually revert to a previous commit prior to this. It's a really cool way to track changes to your place file. And we're going to do just that. We're going to undo our last commit. Now, if you wanted to have more control and revert back to specific commits, I recommend a product called GetLens. It's a plugin that you can use in VS Code. But in this case, let's just do the previous commit. So to do that, click on the source control menu item, and then go to the ellipsis, commit, and we're going to click on undo last commit. Okay, and then you'll see that file just pop back into the stage changes, and then we can actually remove it from the stage changes, and then we can click on discard changes. If you click that, it will actually remove it back to the previous state. So we've just uncommitted the previous commit to the repo, we've unstaged it, and now we're gonna undo the last action on it. Okay, and there we go. Go ahead and close Roblox Studio if it was open, because you have to reopen this file since it's changed since it's been loaded into memory. Go back to your project, open the RBXL file, and you'll see that the part is no longer there. Let's see this all in action. I've been working on a project, a tower defense game, where zombies will be walking a specific path. Now, I don't want to be setting those values individually. I want to be able to paint a path, and that's what I did. I used the paintbrush and I basically painted a path, and then I created code using the pathfinding service that will allow the zombie to walk that path. So if I click play, let's see what happens. So that dummy over there is walking the path that I painted, and then there's also some little spheres that are being placed just to kind of, follow what the code's doing. And then if you see in the output, I'm actually outputting the various vector positions. The reason I'm doing that is instead of relying on the path service, the pathfinding service every single time when there's going to be a live game, I'm actually going to save these values in a class that I can reuse to make sure it's always going to give me the exact same positions, and it's going to be super fast. I don't have to call the pathfinding service. So let's go look at the code. We are back in Visual Studio Code, and let's go over some of these files that I've been working on. So one thing I really like about doing this in VS Code, it just kind of gives you the ability to really focus on your code, setting up classes. Well, in this case, it's almost like pseudo classes because I'm using tables in Lua. But you can set up your folders and just organize your code really well, kind of, I think using this approach. And then of course you got your Git for version control, so everything's being tracked, better vision into what's going on coding wise, more control over it. So essentially in the server scripts, I've got the path.server.lua code, and what I'm doing here is, you can reference different parts by referring to the workspace entry. So I'm setting up various variables, and then I'm calling the pathfinding service. And what I'm doing over here is just saying cobblestone. You're allowed to walk on cobblestone, but not any of the other materials. Okay, it's just a property you can set on the pathfinding service. If I were to set this maybe on brick, set it to 0, which is the lowest integer, then it will allow the and everything else was math.huge. I can now draw a brick path and the zombie will follow that path. Okay. And then other things I'm doing over here, I'm now including some enemy modules. I'm calling them class modules, but again, they're kind of pseudo classes. I'm trying to replicate what I do in other languages, like in Java or in C#, where I'm using classes. So in Lua, you can do that using tables, and I'll show that class in a little bit. But essentially, I'm including that code in here. Let's go look at that code. So the enemy class module 1, that is going to be in my enemy management folder, and then I've got modules, a bunch of modules that I'm calling underneath it. So if we click on enemy class module, in here you can just see some basic code to call this as a singleton. And there's some functions where I can equip weapon, I can get the position, and then I basically return the enemy class. I don't want to go into the nuances of creating kind of like a pseudo class using tables, but this is the code. One thing I did want to talk about here is I am actually also including the zombie values. So this is the second round of this game implementation. At the beginning, I was just always relying on the pathfinding script to output all the values. I've then gone and grabbed that from the print statements, and I've actually entered them here into a variable. Okay, so that was output from my script. I've entered it in here, and I'm just returning all those values. So if we go back to enemy class module, you can see here the position is being set to that zombie value that comes from that variable that's pulled from the zombie path values module. Okay, but again, I don't want to get into the code too much. This is not what this video was meant for. It was just kind of to show you the ins and outs of setting up Rojo with Roblox, how to install all the software, how to get it going, and just kind of how you would be developing in it. Thank you for watching this video. I hope you've learned something new that you can apply to your games. I wish you nothing but the best. Millions and millions of downloads, millions and millions of dollars, doing something that you love. This is DevTotal, over and out.